Klarna just replaced 700 employees with a single AI chatbot.
Yeah, it's staggering shift, honestly. I mean, Duolingo just cut 10% of its translation team.
For the exact same reason.
Right, exactly. And those are just the big names.
Goldman Sachs estimates AI could replace 300 million jobs globally. It's not a scare tactic. It's simply the current data.
Absolutely. The people who survive this shift aren't necessarily the smartest ones. They're the ones who learn to work with AI. They figure it out before the rest of the industry catches up.
Welcome to the deep dive. Today, our mission is intensely practical. We're unpacking a specific AI engineer roadmap. It's designed for you, even if you are starting from absolute zero.
We are covering 5 distinct levels to future-proof your career. And the best part, you do not need a computer science degree for this. You don't need complex math theory either. You simply need to follow the path.
Before we climb those 5 levels, we must define the game. What are we actually playing here? There's massive confusion out there. People constantly mix up data science and AI engineering.
Oh, it happens all the time. That confusion sends a lot of people in the completely wrong direction. Here's a simple way to think about the difference. Let's use a house analogy.
I like analogies.
A software engineer builds the actual house. They pour the foundation. They build the walls, the roof, and the doors. They create the structural integrity.
Right.
An AI engineer, though, makes that house smart. You add the sensors that turn on the lights.
Yeah.
You add the voice assistant for the music. That is your specific layer.
So you aren't building these algorithms from scratch. Instead, you take existing intelligence. You elegantly plug it into real-world products. You solve problems with practical tools.
Exactly. You don't need to be a math genius inventing new algorithms. You just need to know how to pick the right tools. You make them work together seamlessly.
It's like we are moving from building the engines to simply driving the cars. We are operating the machines now. We just need to know how to steer.
That is the perfect way to look at it. You are the driver. The frontier models, well, they're your engine.
2-sec silence. I still wrestle with prompt drift myself, the unpredictability of it all. It can be quite humbling. So we aren't building the brain, just the nervous system.
Precisely. You're wiring the connections. You let the massive pre-trained brains do the heavy lifting. You just direct their energy exactly where it needs to go.
Exactly. We connect existing intelligence to real-world applications. Now, we understand the job itself, but you cannot build a skyscraper on sand.
No, you definitely cannot. We must lay the groundwork first. We have to do this before touching shiny AI tools. We use the SALT framework.
Let's break down the SALT foundation. The S stands for software fluency. Specifically, you need to learn Python. Python is the language of AI.
Yeah, almost everything you do in this field runs on Python. It's actually one of the easiest languages to pick up, but beginners often fall into a nasty trap.
They fall into tutorial hell.
Yes.
You watch a 3-hour coding video, you feel like you completely get it. Then you open a blank file, your mind goes completely empty.
The fix is incredibly simple, but people resist it. You must learn by doing. You can't just watch passively. A tool like cloud.Tech forces you to write code immediately.
It makes the concepts actually stick in your brain. You need to focus on 4 core things. Variables are first.
Think of variables as digital buckets. When that massive AI brain sends back an answer, your program needs a bucket to catch it.
Next, you need lists and dictionaries. That's how you organize lots of data. If the AI returns 50 different customer names, you need a structured way to hold them.
Then you move to functions. This is how you write reusable code. You package a set of instructions together. You avoid repeating yourself.
Finally, you have loops. Loops make the computer repeat a task automatically. If you have 100 emails, a loop processes them one by one. You write the code once.
That covers the software fluency part. The A in SALT is API architecture. Once you know Python, you need a way to talk to the AI.
APIs are how models receive your requests. The easiest way to picture it is a waiter at a restaurant. You are the customer sitting at the table.
And the kitchen in the back is the AI model. You don't walk into the kitchen yourself. You tell the waiter what you want.
They relay your order to the kitchen, then they bring your cooked food back to your table. APIs work exactly the same way.
In practice, you use Python's requests library. It acts as your waiter. It sends those digital messages for you behind the scenes.
Now for the L, that stands for lifecycle and version control. Specifically, we're talking about a tool called Git.
Every professional project involves mistakes. Code breaks all the time. Features get deleted by accident. A tiny typo can crash an entire server.
Panic sets in. Git is the safety net. It lets you roll back to any previous version. It tracks every single change you make over time.
It is basically an undo button for your entire code base. GitHub is the website where those saves live online. Every single tech company uses it today.
Finally, the T is the tech stack. This is building end-to-end. You need a database, like MongoDB, to store user information permanently.
You need a backend, like Flask or Fast API. That handles the unseen logic. And you need a front end, like React, for the visual user interface.
Can't we just skip to the AI stuff and learn Python later?
You really can't. Without Python, you have no way to communicate with the models. You would just be staring at APIs with no way to connect them to anything.
No, Python is the absolute necessary foundation for everything else. Now that the foundation is poured, we move to level 2. It is time to invite the AI inside.
This level is controlled intelligence. You are finally using the best models available. Let's start with the OpenAI API.
You have probably used the ChatGPT website, but as an engineer, you interact with it completely differently. You write code to automate it.
The difference is massive. Instead of manually typing into a chat box, your script runs things automatically. It operates at superhuman speeds.
Think about a script processing 100 customer emails. It flags complaints instantly. It extracts the emotional sentiment in seconds.
It sorts them into positive, neutral, or negative categories. You do not touch a single thing manually. Your script handles the entire inbox.
The prompt you write in the code is so simple. You tell the model to act as a helpful assistant. You ask it for the sentiment.
You ask it for the main problem in one sentence. You wrap that in a Python loop. It processes an entire inbox instantly.
Once you understand how to automate OpenAI, you explore HuggingFace. HuggingFace is an incredible resource. Think of it as the app store for AI models.
The best part is that most of it is completely free. You don't have to rely entirely on expensive, closed models.
It handles so many different tasks. It handles language translation, it gives you image descriptions, it handles sound transcription.
You just pick pre-trained models off the shelf. You run them locally. If you want a structured way to practice all this, look at DataCamp.
They have an associate AI engineer track. It covers exactly what you need to master these tools. Is Hugging Face just a repository for text generation models?
Not at all. Text is just the beginning.
Yeah.
It has thousands of models for analyzing images, processing audio files, and translating spoken languages in real time.
No, it offers audio, vision, and language translation models too. Sponsor. Generic models are great. But in 2026, companies don't want a generic AI. They want an AI that deeply knows their specific data.
That brings us to level 3, Intelligent Systems and RAG. This is the heart of the roadmap. This is what companies are actually paying big money for.
Let's define this jargon. What is ARG? Giving an AI your custom data to read before it answers, that is the core idea.
Imagine you have a 500-page policy manual for a company. A standard model, well, it does not know what is inside that specific manual.
If a customer asks about a niche return policy, the model might just guess. It hallucinates. Argy fixes this problem entirely.
There are 4 clear steps here to make it work. Step 1, you break that massive manual into small, manageable chunks.
Step 2, you turn those pieces into embeddings. Embeddings are just coordinates. It mathematically turns words into numbers.
Exactly. The AI understands those numbers deeply. If 2 concepts mean similar things, their numerical coordinates sit close together.
Step 3, you store those numbers in a vector database. Tools like Pinecone or Weaviate are built specifically to hold these coordinates.
Step 4 is the magic. A user asks a question. Your system rapidly searches the database. It finds the most relevant pieces of information.
It feeds those specific pieces to the AI. The AI reads them. Then it answers the user. It sounds like an absolute expert on your company.
Here is a prompt example you would write in the code. You tell the AI, use this context, don't make things up.
You pass it the chunk containing a 30-day return policy. The user asks, can I return this laptop after 40 days?
The AI confidently says no. It bases that answer purely on the reference notes you just handed it. It doesn't guess.
It is brilliant. We also have LangGraph and MCP in this level. LangGraph allows the AI to think in logical steps.
It is fascinating. The AI can decide to search the web, check a database, and then write a summary. It follows a workflow.
MCP stands for Model Context Protocol. It provides strict rules for external tools. It tells the AI exactly how to use a calculator safely.
It creates boundaries.
Yeah.
You don't want the AI doing whatever it wants. MCP acts as the supervisor for the tools it accesses.
2-sec silence. Whoa! Imagine stacking Lego blocks of data, scaling that up to 1 billion queries across an entire company's history.
It's truly staggering.
Does R physically alter the AI model's core training?
It does not touch the core training at all. The underlying model remains exactly the same. You are simply sliding a cheat sheet across the desk before it speaks.
No, it just gives the AI reference notes before answering. We now have a brilliant, customized AI running perfectly on our laptop. We arrive at level 4.
Putting apps online. How do you let 10,000 people use your app without it instantly crashing? That is a completely different engineering problem.
We start with Docker. Every developer knows the pain of sharing code. You say, it works perfectly on my machine.
But you send it away, and it breaks immediately. The client has an older version of Python, the libraries clash, Docker fixes this massive headache.
It wraps the app in a protective container. It packs everything the app needs to run inside that bubble. It is entirely self-sufficient.
It runs identically anywhere in the world. It is completely consistent. You eliminate the environmental variables that cause random crashes.
Then we have cloud hosting. You cannot run a popular app from your bedroom laptop. You use AWS or Google Cloud.
You put your containerized app on their massive, powerful servers. This is how you dynamically scale up during sudden traffic spikes.
If 1,000 people log on at once, the cloud handles the load gracefully. It spins up more resources automatically.
But there is a catch. Every API call to an AI model costs actual money. That brings us to Redis caching.
This is the secret weapon of professional engineers. It is pure economics. Every time you ask the AI a question, a computer somewhere burns energy.
You pay for that energy. Imagine 1,000 people asking for the exact same return policy. Without caching, you pay for 1,000 separate AI generations.
The bill adds up incredibly fast. Redis solves this beautifully. It stores the answer the very first time it is generated.
It returns that saved answer instantly the next 999 times. The cost for those repeat answers is absolutely zero.
It is the difference between a hobbyist leaking money and a viable tech business. Is Docker literally just a heavy virtual machine?
It is very different from a virtual machine. A virtual machine loads an entire heavy operating system. Docker just isolates the app and its immediate dependencies, making it incredibly fast.
It's much lighter, packing only exactly what the app needs. We finally arrive at level 5, managing a professional roadmap, also known as LLMOps.
The app is live. Millions are potentially using it. It is cheap to run. But is it actually giving good answers? Or is it embarrassing the company?
You must shift your mindset completely here. You go from being a builder to being a business owner. You have to monitor the outcomes constantly.
Models hallucinate. They get things wildly wrong. You cannot manually read 10,000 automated customer service chats. We use DeepEal for this.
It runs automated quality checks continuously. It flags inaccurate answers. It catches unhelpful or off-tone responses before PR disasters happen.
It is your automated quality assurance team. Then we have analytics. Tools like Postfog track actual user behavior inside the app.
You see where users get frustrated. You see exactly where they drop off entirely. The data tells you exactly what parts of your app need fixing.
Finally, we have model routing. This is incredibly important for long-term efficiency. You don't need a supercomputer for every single question.
You send simple FAQs to a fast sheet model, like Claude Haiku. You only send complex, nuanced tasks to a powerful model, like Claude Opus.
Model routing is like having an ecosystem. You don't ask the village elder to chop wood. You don't ask the lumberjack for cosmic wisdom. You match the task appropriately.
That is a very philosophical way to view it. It makes perfect sense. Isn't routing between different models overcomplicating the architecture?
It adds a routing step, sure, but the payoff is undeniable. The cheaper models respond faster, and they cost a fraction of the frontier models.
No, it saves massive amounts of computing money and time. This brings us to the end of our roadmap. Let's do a big idea recap.
We covered a lot of crucial ground today. Becoming an AI engineer in 2026 isn't about being a math genius. It is about consistency.
It's about laying a solid salt foundation. You connect APIs cleanly, you ground your data strictly with RAG, you deploy safely in containers, you monitor your operations constantly.
A smart doorbell is totally useless if the walls fall down. Start with level 1 today. Learn Python. Build a simple website first.
The high salaries exist because it is hard, persistent work, but it is deeply achievable. You just have to follow the roadmap step by step.
Don't skip the basics. Put the time in. You will be miles ahead of the curve before the rest of your industry even wakes up.
We've spent this time talking about how AI engineers connect tools to automate tasks. But as models get smarter at coding, how long until the AI engineer relies on an AI to automate the AI engineering roadmap itself? Something to ponder. Keep exploring.